So today we'll start Flume. Okay. So do you have any idea about what is Flume? What is Flume? It's streaming tool. Okay. So streaming technology. Okay. So Flume is a streaming technology. So we have first what is streaming? What is streaming? What is streaming? Any idea? Live data. So if any data is live, we say streaming. No. Anyone? Any idea about what is streaming? So continuous flow of data. Continuous flow of data. Stream means continuous flow of data is called streaming. Continuous flow of data is streaming. Example, web server. Web server. So let's take web server. So web server or application server. Web server or application server. Application server. So in this application server, we deployed some application. Example, online shopping application. Online shopping application. So we deployed online shopping applications throughout the world. Throughout the world, many people are connecting this server. Many people are connecting this server and doing transactions. So now many people are connecting this server. Many people are connecting this server and they are doing transactions, buying items, buying electronic goods, buying home needs, any items. They are doing shopping through this online shopping application. Okay. So for every transaction, it generates logs. In web server, they write log. So for every transaction, they are writing some log like transaction started. So browsing particular item, browsing electronic goods, browsing mobiles. So for every transaction, they are generating logs. Once selected cart selected, purchased items. Like that, every transaction they are writing logs. So this log is continuously generating, right? So if any data continuously generates, we call that data is streaming data. If any data continuously generating, we call streaming data. So through the Flume, we connect to streaming source. So we create connection to Flume with any streaming source. So example here I am showing log, but we can create connection to any streaming source. Then we can store this streaming data into Hadoop cluster. Main purpose of Flume is read data from streaming source and write it into Hadoop cluster. Hadoop cluster. This is one scenario. One scenario, people are buying different items from this online shopping application For every transaction log is generating, we create a connection with this log to Flume. What Flume do? If any event is generated, if any event is written in log, Flume captures that event and writes into Hadoop cluster. So main purpose is Flume reads data. Flume reads data, reads or capture data from streaming source and writes into Hadoop. Not only Hadoop, you can specify destination. Main purpose is reading or capturing data from streaming source and writing into Hadoop. This is main purpose. Not only Hadoop, you can configure any other source or destination also. But main purpose is capturing data from streaming source and writing into Hadoop. So this is one scenario. Online shopping application deployed into web server. For every transaction in web server, we created log. So application writes log. We are capturing that events and writing into Hadoop cluster. What is the use of writing this log data into Hadoop cluster? Why we are writing streaming data into Hadoop cluster? For any purpose, maybe. See, we have MapReduce application, and we have Pig scripting, we have Hive, and we have Spark. By using these technologies, we process this data. Example, we want to know today how many people buy Samsung mobile. We want to know how many people browse Samsung mobile. Example, lakhs or not lakhs, crores of customers log in into online shopping applications, right? Crores of customers. Each customer, we cannot say each customer buys products. Some people just browse and close application. Some people add items to cart and finally they drop, right? So different person do different transactions in our application. So what we are going to do, example, some people buy mobile. In that mobile, some most of the people browse Samsung latest version. Then we want to find those people details. We want to find those people details. So if any person browse Samsung with new model, everything, anything browse, it will write into log. Then we are capturing and we are writing into Hadoop cluster. Then we write the Spark application. Spark application reads that logs and finds who browse Samsung mobile. Then it prepares one list. Then we send this information to the Samsung vendor or Samsung company. Samsung company says that so many people visited our site, so many people browse your this item. We show this statistics to Samsung. Samsung may provide some different discounts or some offers. So based on the people interest, they may give different offers, right? So we apply that offer information again into our site. So like to take any future decisions, one more scenario. So Hyderabad, most of the Hyderabad people browse Vivo latest version or OnePlus 6 latest version. Many people trying to buy OnePlus 6 latest version from Hyderabad region. Then we want to intimate OnePlus management or company so that they can provide more mobiles in Hyderabad region, right? So like that, management may take decisions based on our data and processing information. So if any data written into streaming source, we capture that data by using Flume and we write it into Hadoop cluster. By using Flume, we cannot write any analytics. Just Flume purposes, it will capture data and writes into Hadoop. It cannot do any other things. This Flume is just capturing or reading data from streaming sources and writes into specified destination location. And once data is presented, we write either MapReduce application or Pig scripts or Spark application. Nowadays, we are using Spark, or we may write machine learning algorithms to take decisions, or AI related algorithms, or data science related algorithms. Anything. Once data is presented in Hadoop, then on top of that data, we apply different algorithms. It may be Spark algorithm, it may be ML algorithm, it may be other algorithm. So first we need data, history of data, right? So we are capturing that data by using Flume. And there are multiple streamings of technologies are there. Streaming technologies available in the market. Not only Flume, and we have Storm, and we have Kafka streaming, and we have Spark streaming. Some streaming technologies provides analytics. Some streaming technologies just capture data and writes into destination location. Okay. Some streaming technologies capture data and writes message data into destination location. And Spark streaming and Storm provides live analytics. Live analytics. See, some places we need live analytics. Some places we need batch analytics. We have live analytics and batch analytics. Live analytics and batch analytics. So when we implement live analytics, when we implement batch analytics, example, we have GPS systems in different traffic locations, different GPS systems. So traffic traffic uh, people maintain cameras in different locations. All the traffic signals, they put cameras in all traffic signals. Okay, then we used Flume to capture data from all these cameras, writing data into one log location. So they have a traffic server. In traffic server they have log system. So all these cameras writing data into log server, traffic server, assume traffic server. Then we are capturing this data, and Flume is writing into Hadoop cluster, Hadoop cluster, Hadoop cluster. Then Flume writing data into Hadoop cluster. So these are different traffic cams in different traffic signals, cams in different traffic signals. Okay, so we have this is the system. Multiple cams are fixed in different traffic signals. Each camera writing the data into traffic server in log location. Then we are configured to point that log with Flume. Flume capture, if anything writes into here, it will capture and writing into Hadoop location. Then we return some processing application. Say we return Spark processing. Spark processing. So we return Spark processing. Okay, we return Spark processing application. Assume we want to find a suspicious person in traffic. So camera captured suspicious people. So there is one person, suspicious person in XYZ traffic location. XYZ traffic location. Camera captured person and it written into Hadoop cluster. We return processing application. When this processing application is executed, maybe end of the day. But suspicious person uh, is at morning, found at morning 10 a.m. We are running this application at assume night 10 p.m. We found this information, suspicious person information at end of the day. What is the use of this here? No use, right? Batch analytics. When batch analytics are useful, whenever we want to take decisions, right? This is not suitable for live analytics. So suspicious person information, if you find on this part, if you find suspicious person information on this part, we can send this information to next traffic signal police, right? So that they can catch that suspicious person. So Flume is not for live analytics. If you replace this with Spark streaming or Storm streaming, if you replace Flume with Spark streaming, Spark streaming or Storm streaming, then you can apply live analytics. Every 2 seconds or 3 seconds or every 10 seconds, we can run analytics. We have a feature in Spark streaming and Storm streaming. Every 10 seconds, you can run analytics. Yep. So we are discussing just streaming here. If you use Spark streaming or Storm streaming, you can apply live analytics. Means batch analytics on micro batch analytics. Every 5 seconds or 10 seconds, we can run analytics. So that if it finds any suspicious person, immediately it provides information about suspicious person. Based on this information, we can send signal information to next traffic signal police so that they can capture this suspicious person. Then if you use batch is useful in previous application. Previously we discussed web application, right? End of the day, we are preparing some we are running batch analytics. In batch analytics, we need history of data. Example, uh, one more example. There is one supermarket. They want to take some decisions. So next to coming festival is Deepavali, right? They want to they want to take 10 years data, and 10 years data they want to do some analysis. What are the products last 10 years onwards selling high or more in Deepavali week, so that they want to order more more items, more quantity of corresponding that items, right? So instead of say we don't have, then we can buy or we can purchase uh, more volume, then we can increase our sales, right? So supermarket wants to take that kind of decisions. They want a history of data. So history of data they can store into Hadoop cluster. Then on that history of data they will apply batch processing. But here streaming means continuously we are reading data and we are storing into Hadoop cluster. We are storing into history data lake. So every day we are applying end of the day or every week or every month we apply some analytic, and we based on result we take decisions. No, no. Here, what we are doing based on our requirement. This is traffic. So traffic, we are getting data into log. Then in Spark streaming, based on some symbols or algorithms, they designed finding suspicious person. So every 5 seconds, this application is running, and if it finds any matched images, it will display that result. Yep. Once we get that data, we can send message to immediate next to traffic signals. One more. This is one scenario. Previous scenario. Example. This is web server. This is web server. Not traffic signal. Web server. Web server. This web server is for bank. Bank web server. Bank web server. Okay, this is bank web server. So different places people are doing transactions, credit card transaction. So one person did transaction in Hyderabad, immediately same transaction happen in USA. So one person cannot do transactions from say different locations, right? So we want to find fraud transactions. Immediately we want to find that system information, both the systems information, and we want to notify to credit card user. A user, you did transactions in Hyderabad as well as USA. Have you done both the transactions? We want to notify the user. If user says okay, then we can leave. If user can complain, right? So in USA, how can I do transaction in USA? I'm in Hyderabad. Then immediately bank people identifies the system details, internet details, everything, and they send that information to some crime department or police department to find that person. So in this way, we want to take decisions. So for that, we use live analytics, right? Live analytics will help. So web server we can use for batch processing and live processing. So batch processing, when we do batch processing, every day, end of the day, we want to find how many transactions did by using credit card. One person doing multiple transactions in every day. We want to find end of the day what are the different transactions done by XYZ person. So example, when Friday every Friday person is buying or booking some bus tickets. Bus tickets every Friday is booking bus tickets. So there are multiple sites offering bus ticket bookings, right? We want to give this information to different websites, Redbus or Abibus, so that they provide different offers, right? So Redbus, we want to give this information to every time he is booking tickets from Abibus. We provide this information to Redbus. Then Redbus people may provide some discount information to this person. So this batch analytics helps to take decisions at the end of the day or end of the week, end of the month, end of the year. So once data, huge volumes of data is presented, we apply batch analytics. Okay. On small data or some data, if you want to apply live analytics, we go for these kind of technologies. Okay, so Flume is for different purpose and Spark streaming is for different purpose. Flume has Flume has three core components. Three core components. Three core components. Source, source, channel, source, channel, sink. These three core components. These three core components are part of agent. So agent is main component. Agent is main component. So source, channel, sink, these three are part of agent component. Okay. For every application, for every application, we create one agent, one agent or multiple agents. Each agent, each agent has source, channel, sink. Source, channel, sink. Let's discuss Flume architecture so that you understand what is the purpose of source, channel, sink. See, we have different streaming sources. One is web server, web server, and it is generating continuous logs. It is generating continuous logs. And we have database servers, database server. Database server also continuously generating log. Database server is continuously generating log. And we have different GPS systems or traffic cams. These writing data into some log, some server. So these all streaming systems writing data into some log location. Then we are creating from Flume agent. Flume agent has three main components: source, source. So source we configure with streaming source. Source we create connection between streaming source with our Flume source. What source do? Whenever any event is generated here, whenever any event is generated here, source reads that event and writes into channel. Writes into channel. writes into channel. Channel is a temporary place. We can use different channels. We can use different channels. I will explain what are different channels are available. Different channels like we can use like uh, file channel and memory channel. Kafka as a we can use Kafka as a channel, DB as a channel. So we can use different channels to store this data. And once data is presented, then next one, sync reads data from channel. Sync reads data from channel. Sync reads data from channel and writes into specified location. So we have different syncs. If you use HDFS sync, HDFS sync, it will write into HDFS system. If you use Kafka sync, Kafka sync, if you use Kafka sync, it will write into Kafka. If you use file sync, if you use file sync, if you use file sync, it will write into file. Or you can also use another flume which may has same flow. Then you can configure with another Flume system. It will write into Flume. So you can configure either Flume or Hadoop or Kafka or file system or multiple syncs are there. Most of the times we use Hadoop. So whatever the sync you configure, it will write a data into specified location. If you configure file, it will write the data into file. If you configure Hadoop, it will write into HDFS file system. If you write Kafka, it will write into Kafka message, Kafka topic. We can create Kafka topic, right? So particular Kafka topic, we can configure with the sync, then sync writes into Kafka topic. Okay? Yep. Yep. No, so here you can use Kafka also to give source. Yep. Yep. Why here separate channel? Example, we can directly source to sync we can create, right? So there may be a chance of failure of data. We cannot say from if you give source to sync, there may be a chance of failure of data, right? So first we store that instead of writing directly into destination location, because Hadoop cluster is in different location. Hadoop cluster is in different location. While writing sync to destination location, some network issue, data completely not written, right? We cannot recover, right? That's why we are storing whatever the data we capture, we are maintaining in channel. So for permanent, see, some data is very important. So we want to maintain the data long time. For that one, we use instead of memory channel, we use file channel or Kafka channel or DB channel. If you use memory channel, memory if out of memory issue or there may be a chance of a system crash. We lost channel memory also, right? So we can use a Kafka channel or DB channel or file channel. We have multiple channel types. In a Kafka agent, this is complete agent component. In a Kafka agent, while creating Kafka agent, we specify what is source type, and we create source information. We provide what is the source location, and what is the channel, and what is sync. Then finally we create a source to channel and sync to channel. We create links between source to channel, sync to channel, so that source understand channel information. Whenever it reads events, it will write into channel. Then sync continuously communicate with the channel, reads event and writes into destination location. Okay, so this is complete Flume architecture. Flume architecture. Sometimes like this is our source. Source source is generating continuous data, and we capture this source data with Flume. Flume has source, and we have channel. We have sync, and sync again one more Flume agent. It depends upon our architecture. We may have multiple agents. So sync is writing, source is capturing data and writing into sync channel, and sync is capturing from channel and writing into another source. So we may have this kind of architecture also. So this one is writing into Hadoop. This one may be writing into some other destination, maybe file channel, file. So one sync we can configure with another Flume source. So we cannot say always sync destination is either Hadoop or file system. It may be other Flume agent. Implementing Flume is implementing Flume application is very easy. Flume application is nothing but just creating configuration file. Just creating configuration file. Configuration file. It's simple XML file. Simple file, not XML file. It's a config file. .config file. So implementing Flume application means it's a creating configuration file. In that configuration file, in configuration file, we provide agent information, agent information, agent information, next source information, source information, next channel information, channel information, next sync information, sync information, sync information, next source to source to channel, source to channel, next sync to channel. We provide configuration of source to channel, sync to channel. This complete information we provide in configuration file. That's it. So implementing Flume application is very simple. Writing one configuration file. Then we have one Flume command. Once completing application, we have Flume command. Then how to run Flume application means we have simple Flume command, and we pass configuration file location. We pass configuration file location. That's it. Implementation is completed. By using Flume command, we say this is the configuration file. Then Flume will taken care. How to start agent, how to start source, how to start channel, how to start sync. Then internally whatever we discussed, right? This is internally implemented by Flume software. Okay. So our development part is we provide first we create agent. What is agent name? What is agent name? And agent with source, agent with channel, agent with sync. Finally source to channel, sync to channel. Then here while running Flume command, we said this is the configuration file. In this configuration file, and we say we give agent name, and we provide agent name. So this is the agent name. Then Flume command reads agent name and reads configuration file. Then it will create agent. Okay. Developing Flume application nothing but creating configuration file with this information. Only one thing we have to know: if you are using different channel, for file they given different channel in details, for memory they given different details, for Kafka they given different channel information. If you want to create a file channel, they give different details. Memory they give different details. For DB they give different channels. So we have to know what are the channel information available for file and DB, Kafka, memory. Okay. Yeah, what type of channel we want to use, because channel is very important. Here we keep our data for some time. Once data sync reads data from channel, we don't want that data, right? So once sync successfully writes into destination location, we don't want that data, right? Yep. Channel is a place where we store data temporarily. Yep, where we store data temporarily. Once sync writes the data, but once sync writes successfully into destination, we don't want that data in channel, right? So Let's see default configuration file. Flume provides Flume installation path. Flume installation Flume installation location. Flume installation has default configuration file. Configuration file. Configuration file in. Let me show that location. In Cloudera, cd slash under root under usr under lib there is flume ng ls see here cd config. Here you will see one default configuration file flume conf. Flume-conf properties.template. I created this file flume conf. So flume-conf properties.template. Let's open this template file. Cat flume conf properties.template. So this is sample details. So first we are providing agent. Agent name is agent. You can take any name. It is not mandatory to take agent. You can take Srinivas. Then you have to give that information what is the agent name at command. While executing command, agent name is Srinivas. So you can take agent name any name. In this sample they taken agent name is agent. And source name is saying sequence gen src. And channel name is saying memory channel. Sync name is saying logger sync. Then so this is source information, source details. For this source we are getting data from sequence. And channel is saying memory channel. Yep, they given sequence, it's a command, Linux command. So in this place we configure as some other file or any other web server log or DB server log or some other file location, log file location or network port number. If anything write in network port, we can read. Just don't copy, just understand this sample. We will write some configuration file later. I will show this flume conf file. Let me open uh, cat flume.conf. So no data is available here. Let's see. We are saying agent dot sync dot logger sync dot channel. We are saying sync. This is channel name. We given channel name, right? So this is the channel name. We are giving sync. This is channel name. So if you want to read data, go to this name and read data. Next, channel type we are saying this is memory channel. So if you say memory, it will write data into RAM memory. RAM memory. If you say file, we give path. Where is file path? If it is memory, we just say memory. it will write in RAM. Okay, so that's it for today, and tomorrow class we see complete practicals, different examples. Okay, we read from file and we write into, uh, first we read different examples, we will see tomorrow class.